Hello everyone, it's really good to see you here. So today we are going to solve a Leetcode problem, which is number of islands. It's a very famous problem, and the technique which or the data structure which we use here is depth first search, that is DFS. So how we can approach this problem is that we have given a grid which has only zeros and ones, and what we have to check is like an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So let's suppose here 1 is land and 0 is representing water. So a portion is called an island if each and every part is connected or surrounded with some water. So here you can see that these ones, all of them, like this one, and here how it goes is it is surrounded by water on the other side, so the island number here in this case is 1. So let's see this with an example. So let's suppose we have given this list or grid. So what we can do is we can apply DFS technique, which goes like we have to check. So if you are at this position, you have to go upward, which is I minus 1j. You have to go in this direction, that is ij plus 1, then downward, which is I plus 1j, and then leftward, that is ij minus 1. So talking about this particular ones, we have to apply DFS only when we encounter someone. So let's suppose if we got this one, then what we do, we just call DFS in all directions. So there may be a possibility that for some points it is not able to call itself, because here you can see that this is out of bound, and also here this is also out of bound, but these two are possible answers. So what we do, we just make that particular one as minus 1. So here we are making this minus 1, and again we are calling DFS for this. Hence it is connected, that's why it is also become minus 1. Then it is going to call upward, which is already minus 1. Then here it's not possible, then here it's 1. So, and then here it's also 0. So it is also not considered an answer. Now once it's called, you can see that it also become minus 1. Then he repeat the process. So it just check in all the 4 directions, and again when this portion is also left, because this is covered by this particular one, right? So it is also going to check for all the 4 directions, and you can see that it become minus 1, and each and every direction would be checked. But after this particular DFS calls, it is not able to call for this one, right? So now our count become 1, because we have successfully executed one DFS call here. Now what we do, we just again traverse throughout our grid, and you can see that all the ones are now become minus 1 and the rest are 0. So when we encounter 1, we just make it minus 1, and we again call DFS for all the direction. So here what we are doing is we are calling our DFS function 2 times. That's why now our count become 2. So we'll return 2 as our answer. So it's a very easy approach. Now let's dive into its coding part. So here you can see that n is the row and m is representing the column of the given grid, and c is used to have the count, like how many islands are there. So we are just iterating throughout the grid, and once we found an element which is equals to 1, then we just call DFS for that particular one, and then we increment our count. So here you can see one DFS call started, it will end up like making all the 1 into minus 1 till the point it is connected in the 4 directions, right? So here let's see how DFS function works. So this n is representing the row and m is representing the column, and then this is the base condition. So let's suppose if I become negative, or I become greater than equal to the given row value n, or j is less than equals to 0, or j become greater than equal to m, or if the element at that particular point is 0, then we simply return from there. We don't have to do anything. Also, if our grid is equals to -1, because we had already done our operation on that particular one, that's why we return from there. Else, if all these conditions are not satisfied, then what we do, we just simply make our grid ijs -1. And then we again call our DFS function. So what we are doing is we are firstly making this particular element -1, and then we are calling DFS function in all four directions. So you can see like this. So yeah, at the end of it, you each time whenever you call your DFS function, it just increment your C count, and at the end of it, the number of DFS call is equals to the number of islands present inside that particular grid. So let's try to run this up. So yeah, now I'm submitting this. Okay, so this is the solution to solve the problem number of Iceland, and if you want to access the code, then you can check the GitHub link given in the description. And before going anywhere, please do like, share, and subscribe to this channel. And thanks for watching.